What's going on, guys? My name is Brandon, and in a recent episode we took a cast iron pan and we hung some weight off the handle and determined how much weight it took to actually snap that handle off. Then using stick welding, we welded the handle back on, and then we measured how much weight it took to snap the handle off again, and I was blown away by the results. If you want to know more about that video, check the link up above. But that prompted me for this week's video. How much weight will it hold if you repair it with flux core? Well, we're going to find out. Stick around. Alright guys, so here we go. Here's an upcoming sneak peek of this winter's project, but enough of that. You're going to be hearing and seeing more about that over this coming winter, but here's the deal. So here's the pan. We actually welded it up with a stick welding process and the handle busted off. So we know the results of what the pan actually held when it was new. We repaired it, hung weight off it, and now we're going to check what it's going to take to break it off again using flux core. Now, although this isn't going to be a perfectly scientific or perfect repair, because obviously now it's breaking in a little bit different area, and there's going to be some minute differences between obviously the original and now that it's going to be repaired again, it will give us an idea, a rough idea of how strong it is. You know, is it going to break off at 10 pounds? Is it going to break off at 50? Or is it going to break off at 100? So I'm going to talk to you guys about what I think is probably the next most common process. If you guys had some cast iron and you wanted to repair it, you'd probably either do it with stick, which is why I started with that process. Probably the next is going to be using flux core. Now I'm going to say this again, guys, and I've said it in all my cast iron videos, I think, and there's disclaimers down below. This video is not for you guys to find an old cast iron pan and restore it by fixing cracks or breaks. I'm not advocating anyone do that. In fact, I would highly discourage you doing that unless you're just going to hang it on the wall as a showpiece. There's just too much liability in repairing cast iron because it goes through hot and cold cycles that eventually cast iron is known, or repaired cast iron is known to fail eventually. It will never be as strong as it was before it broke. It becomes brittle after you weld it. So for that reason, I'm going to encourage everyone, do not repair your cast iron pans. I'm using a pan because I believe it's a material that we can all agree on that that pan's made of cast iron. And if you don't believe it is cast iron, click the link up above. I've got 5 different ways to show you how to determine if a part is or isn't cast iron. Old school, you'd braze it. You'd use flux and you'd use stainless steel rod. Well, we're trying alternative methods. Not everybody has that equipment. You know, maybe all you have is just a flux core welder. And if that's all you have, how well does that compare? Is that a viable process to use to repair? We're going to find out. So there isn't really anything that I can do about that weld being in that zone. It is what it is. This is something that we're just doing to test, to have fun, but it'll give us a general idea. So what I'm going to do, guys, I'm going to start by beveling this edge just to give the weld a place to go. And I'm going to bevel and weld this edge. And do the same thing here, and I'm going to do the same thing here. And we're going to go through, and I'll talk to you about the process on welding it. Now, if you're wondering if welding cast iron on both sides makes it stronger, well, I have an answer for that as well. So click that link up above, and you'll be able to know. So for this repair, I'm using my Transsteel 2200 by Fronius, and this is a multi-process welder. For wire, we're going to be using 30 thousandths flux core wire. And I'm just going to mount it up, get it fed through the gun, and off we go. Feed that into there. There. So one of the first things we got to do to set up our welder properly is we got to know the material that we'll weld in, and we got to know the thickness. So I like to use this little handy gauge. And you can see here, probably a little bit bigger than 1/8. Yeah, it's just about 3/16 right there. So, I don't know. So we're not going too hot. I'm going to call it probably 1/8 inch, just whisker bigger than 125 thousandths. This machine will do stick, TIG, and also do flux core and MIG. So I've got it set in synergic mode right now, which means that all the parameters are based off the material thickness and the filler metal that you're using, and it calculates it all on its own. So we're going to jog over to wire material thickness. And the material thickness, we're going to call that about 3.5 millimeters. So we'll go 3.5. And you can see all of the material we can pick, which would be steel, stainless, metal. We'll toggle down to self-shielded. And I'm using 30 thousandths wire, but there is no program for 30 thousandths wires. There's no program, so we'll have to go 35 thousandths. So I'm guessing it's going to probably be a little hot, maybe? I don't know. We'll just have to try it out. So, and that's all automatically giving us 15.1 volts. It kind of factors in itself. If we were using a gas, we'd have to pick our gas down here. 100% argon, 100% CO2, C25, argon, and 2.5. So, all right, let's get going. Now, if you guys want to know all about this machine or what it can do and more of the setting of the parameters, go check out this guy's channel, Milky Cereal 83. Go subscribe to it, and I'll put a link in there as well, because if you have one of these Fronius machines, it'll be super helpful and beneficial for you to check out his stuff, because he's done a lot of the legwork of trying to learn how to set all these settings. So for that, bud, I appreciate you putting out that content for everyone. The recommended procedure to bevel back any of this cast iron is to use a hammer and a chisel and just gently chisel it back to make room. And that's so you don't introduce contamination into the cast iron. But we're not going to do that, and probably nobody else is either on a non-mission critical part. So we're just going to use an abrasive disc and just gently pull back some of the materials to a slight bevel. We'll do the same thing for the handle, and that'll put us in good shape to start welding. Now, just like anything, there are special considerations when working with cast iron. You want to make sure you stop drill your cracks if you have a crack that starts in the middle of a surface. And if you watch my cast iron series, then you'll know about all of that. Check out the video links in this, and it'll just direct you to pretty much everything you'd ever want to know about repairing cast iron. But yeah, just take your time. Prep is the key. And now that I got it all beveled, what I do is I just test fit everything, make sure I fit up nice, and there we go. Got a nice bevel, and we just got to fill all that in with weld. But before we start welding, I'm going to turn on my $60 DIY Fume Extractor. And if you haven't seen that video, go ahead and check it out. This works really good. I use this for welding fumes, and as obviously as you can see, we do a yearly project, rebuild project, so I use that for exhaust. I use that on my street bikes. That works good too. So suck all the fumes out so we can keep the doors closed while we're working inside and we don't get asphyxiated. But check out this upgrade I did, guys. So there's a blower right there. Initially when I did this, it just has a cord that comes off the blower, and I just plug it into that receptacle there and it turns it on. But the issue is that I don't want to hear that fan running all the time if it doesn't need to be running. So what I did was I picked up a pack of these. They're only like 20 bucks. And what this is each one of these is a module, and you can plug a receptacle into the end of it, and it's remote control, and it does it like between walls. You don't have to aim it at it, and it has like a 100-foot range. So I keep mine hanging off the end of my welding table. And I'll check this out. So when I hit the on button down here, it turns on my exhaust fan and it turns on my room fan. Hear that? So now that is sucking out fumes, and it's also turning on a room fan to keep it cool in here. And when I'm sitting down here and there's no more fumes at the table, I just turn it off and I don't have to listen to that racket anymore. So yeah, go check that out. I'll have links down in the description for these, but yeah, this is good. We actually use these for our Christmas tree lights too. It makes it kind of handy. We have a bunch of different things set up, and it works good because you can turn on each individual one. And like I said, it's all remote, so you don't got to go running around the room to turn on different switches. Now that everything's all beveled, now I tack everything together. I do this before the preheat, so you're not handling super hot parts. So now at this point, guys, if you wanted to do a preheat, which I always recommend a preheat, I think you just get a better chance of getting a better job. I think we can do this without a preheat, but we'll find out. I mean, proof's in the pudding, I suppose. But either way, this is how I would do it. I would not preheat the pan. I would tack it first. Get it held together, because that way you're not fiddling with hot parts. So now I would take this, and however you want to heat it up, ideally put it inside like an oven or a gas grill or whatever it is, but obviously sometimes your part might be too big and you can't preheat it, so you'd have to use a torch. But either way, this is how I would start, so you could get a nice fit up and hold everything together, get your tack on it, and then put it in for your preheat. Bring it out of your preheat, and now just start welding. Most all guides will say to weld an inch and then peen it, and then weld another inch and peen it. I usually don't like going an inch. I like to keep my beads approximately a half an inch long, then I peen it, and by peening it, what that does is that elongates the filler metal, and it just kind of like, basically, in other words, just kneads it into the joint. So this is not going to be a pretty repair. They never are. You know, if you want it to look pretty, you could TIG braze it. That you could make it look real nice, and you could probably stack beads. But because you do end up wetting a little bit of the base metal, you're trying not to, but because you are wetting some of the base metal, you do get some of those impurities that float up to the top. So you are going to get porosity. That's just kind of how it is. But it's kind of a crapshoot with cast iron, depending on when it was made, the batches, how clean it is, whether it's burned, meaning, you know, has it been used in an exhaust system, has it been soaked in oil. But you know, again, this has been soaked in oil, so it's obviously a pan. I doubt it's been probably submerged up to here for any length of time, but the bottom obviously would. But so yeah, so now my next process, I'm going to clean this up, and I'm going to peen. I'm going to add some more weld, peen it, add some more, and peen it. Then we'll hang it off the bench and see what it does. Like I say, this is an alternative to the conventional standard methods that we all know, and I'm not, again, advocating that you try this. This is just an experiment to see how strong this piece is. You know, maybe you have a leg on your wood stove, or you have a cast iron park bench that you want to sit out in your garden. It's got a broken leg. These are all repairs that I've done that have held up and have worked well, and a lot of other people have too. If you read the video comments, cast iron is fun to work with until it starts cracking and giving you problems, and I've had that happen too. Sometimes it's just unavoidable. All right, guys, here we go. Temperature-wise, that actually feels really good. Hear that? Listen, guys. That's usually when cracking occurs, when you hear that sound. That's the material shrinking down. When you weld cast iron, one of the test methods to determining if it is cast iron is if you have a TIG welder, turn your amperage right up, crank it right up, and just, with no filler wire, just hit it right on the corner of a piece of this cast iron, make a little ball, then run a file over it. If that ball is hard, then you know it's cast iron. So cast iron hardens when you weld it. That's why generally it will crack and fail again later down the road.
The reason cast iron has a tendency to crack and the need for a preheat is because it has a tough time with thermal shock, but we'll talk more about that here in a minute.
What's really interesting is that this same wire I've been running in my Hobart machine, and now I'm running it in this, and wow, I'll tell you what a difference just in machines. Same wire, it runs it different. My Hobart is a transformer-based welder. This is a inverter-based welder. It'll run on 120, 240. It's fully digitized, so yeah, this thing is incredibly smooth. I'm really liking this.
So there's a few things that go on with cast iron, and I'll try to keep this kind of general, but the reason you generally try to do a preheat is because it lessens the amount of rapid shock that the cast iron has to take. If you can get the cast iron up to, say, 400 degrees, and then it's starting out from there going to a welding temperature, which is 1,000 degrees, that's just less of a temperature differential between room temperature and between the temperature of what you're welding at. So it's just less of a swing. And then you do the same thing on cool down by putting it in sand or putting it in an insulating blanket. Now, whenever cast iron is subject to heat and cold cycles, like let's say an exhaust manifold, it will be more subject to cracking. And the reason for that is because it's going through constant temperature differentials, hot and cold, and as we've already spoken about, cast iron has a tendency to harden after you weld it. It becomes brittle. That's why it will always break at the toe of the weld, because that's within the heat affected zone of the weld. So when selecting a filler metal, generally you're trying to find a filler metal that has some elasticity to it, in other words, or something that has the ability to stretch or elongate with that expansion and contraction of the cast iron. So if you're welding something that is constantly going through heat cycles, it will have a tendency down the road to potentially crack again because it's going through those swings. If you are repairing a part, like let's say a leg on your wood stove, or even a door to your wood stove that, you know, it gets hot but it's not going through extreme swings, in their slow extremes, an exhaust isn't a slow temperature swing. Your exhaust on your car could go from a freezing temperature on a cold winter morning, and then you start it up and instantly it's going to have basically fire in that exhaust, and it's going to be heating up very rapidly. So it's the quick temperature swings that cause cast iron to fail down the road. If you don't have any temperature differentials, cast iron is a lot more forgiving and the repairs just generally work out better. And by doing a preheat and a post-heat cool down in insulated sand or a blanket, all you're doing is you're just controlling and slowing down that temperature differential, so you're not shocking it. That's pretty much it.
Alright guys, this one side, it's not pretty, but you know what? It doesn't have to be. All it's got to do is hold. Like I said, cast iron isn't overly pretty when you've repaired it anyways. Now I've just taken a scrap of steel and kind of clamped it to the pan, and that way I can be in position. I can have this up vertical and can just weld this right around. So you can see, here's our old weld. Although this isn't going to be a perfectly true test, it'll be good. We've got to go here, all along that groove, down here, and up to there. A lot of guys will use a needle scaler to do this. Basically, a needle scaler, it's kind of like an air-operated chisel, but it has a lot of little points and blunt needles that just kind of like peen the material out. That works really good too. They use a lot of those needle scalers too to remove rust and stuff like that.
I occasionally get comments about using a chip and hammer to peen the welds, and honestly it doesn't matter. The backside of the chip and hammer is no less blunt or sharper than a needle scaler, and a needle scaler is the ideal tool to use when peening cast iron. You could use a peening hammer, an actual peening hammer, but I find that the ball is just, it's a little too much surface area to move the metal, and that's what you're trying to do. You're trying to move metal. In short, you're trying to knead that metal or that bead and kind of like push it into the weldment. That's the idea behind it.
So just like the last video, we've got the pan clamped down to the bench, and we have a bucket hanging off the end of the handle, and the bucket is suspended. Now we will fill the bucket up full of material until the handle snaps off, and then we'll weigh the bucket and we'll see how it compares to the other process that we did. So what do you guys got for guesses? What do you say? Put it down in the comments. I'm totally blown away. I don't know anymore about what to say. I was pretty far off the last time I guessed based on what I know, so I'll probably be off again this time. So put it down in the comment section. Let me know what you think. What was your first guess? Well, we missed the first part of me loading this up, guys, but good thing is it hasn't broken yet, so I'm going to continue to fill this up with all my scrap metal. And we're going to load it till it breaks. So what do you think? You guys impressed yet? Alright, now we're going to start adding sand. what do you think? That's always scary when that does that. How much do you think that broke off at? We're gonna find out. Let me bring you in and show you the weld. And there it is, guys. Not pretty, but once again, it breaks next to the weld. It breaks at the toe of the weld. It always will. Here it actually broke off some of the virgin cast iron that had not broken before. So, but yeah, it always will break at the toe of the weld just because that's where it hardens in the heat affected zone. And here's the handle. You can see there, that's virgin material where it broke. And then again, it broke right next to the toe of the weld. Yep, so just what I thought it would do, but I don't know how much weight it held, but we'll find out. All right, you guys wondering how much this held? I know I am. All right. Ready? Zero it out. Wow, 147.2, that's crazy. All right, guys, here's the math. Now, you're going to have to watch the other video if you want to know how this process compares to the other, but this is what we got. So, the original pan, the handle, before we did any repairs, when it was all intact, it took 218 pounds to break. Here's all the kilogram figures. Flux core broke at 147.2. So, the difference between that is 70.8 pounds between the two of difference, which that difference is a 32% decrease. So if you are going to weld a cast iron pan using flux core, it's going to be 32% weaker than the original part before it broke. So there is a difference. Initially I had guessed that broken cast iron versus non-broken cast iron, the repair would be about 50%. So I was way off. So 32% weaker if you're repairing it. So, but then again, that's the gamble you can't take. So that's why I say don't use this to repair parts that are critical, like pans and stuff you're going to be putting on a stove. You don't want to burn your house down. So that's all there is to it, guys. Like I said, this isn't to substitute the traditional normal methods of, you know, like TIG brazing or oxy fuel to repair it, or using a preheat, post-heat, welding it, peening it, and then cooling it in a sand or cooling it in an insulated blanket. Those are all accepted methods. But, you know, if you are working and this is all you got, it's just a flux core welder, no gas, you know, just a standard flux core welder and some flux core wire. These are some of the things that you could do, and now you have an idea of how it compares and stands up to some other processes. So until next week, guys, I will see you then. Take care, stay safe, see ya. Links down below, new videos every Friday. See you then. Like, comment, subscribe. Bye.